16.1 Log properties. Remember, we have discussed that log functions or logarithmic functions are the inverse of exponential functions. This is really important that we understand inverse opposite. So everything that happens in an exponential function, it is the opposite in a log function. That being the case, we looked at that on a graph, but now we need to remember our exponent rules for exponential functions, and everything here will be the opposite when we go to log properties, okay, because they are inverses. So you should remember this from when you were, gosh, I know they did this in Algebra 1, but I believe they do it before that. When you're multiplying, as long as you have the same base, you're going to add exponents. You have an example right here. Notice that my base is x on both. We are multiplying. So I do 5 plus 3. That is because this is really 1, 2, 3, 4, 5. This is 5x's multiplied. Then you're timesing again by the other 3. So you have a total of 8. 5 plus 3 is 8. Or if you wrote it out, 5 multiplied times another 3 multiplied is a total of 8 x's being multiplied. Got to have the same base. Then, when we are dividing, I should have bolded that and underlined it, dividing with the same base, we are going to subtract the exponents. Okay? So right here I have x to the 8th divided by x to the 3rd. I should subtract those. 8 minus 3 is 5. Or what's really happening, 1, 2, 3, 4, 5, 6, 7, put another one over here, 8 divided by x to the 3rd, which would be 3. Now remember, when we divide anything by itself, it's 1. So this is 1, this is 1, and this is 1. That leaves me with 3, 4, 5 exponent. 5 x's in the numerator. Okay, so the simple fact is I just do 8 minus 3. And then the last rule we have is when you're raising an exponent to an exponent, or they may say power to a power. Either way, we've got an exponent right here with another exponent. We are supposed to multiply those. You multiply. So what this means is I've got x to the 12th if I use the rule. If I write it out, I've got 1, 2, 3 x's inside the parenthesis, but I'm supposed to do that 4 times. So there's okay, if you count that up, 3, 6, 9, 12. So you see it's much faster to just know the rules and multiply your exponents. Okay? Again, that was Algebra 1, so this is not a lesson on exponents. This is a review on exponents very quickly. We need those rules because we are going to take the inverse down here. We have a product property, which product means multiply. Okay? So notice that the two logs are being added. We added exponents when we were multiplying with the same base. Now it's going to reverse. Addition really means that we should be multiplying because we are taking an inverse. So I'm going to rewrite it as log base 3. Notice they have the exact same log bases. That's important because we still have to have same base. Log base 3, so I only write that once. And then I take the arguments, 2 and 4 are called arguments, and I multiply them. So it should be 2 times 4, which should really be log base 3 of 8. Okay? It is the inverse of the exponential rule. We start with multiplying, so we add up the exponents. In logarithms, the inverse, we start with addition, so we will multiply. They are simply inverses. The order in which things are happening changes. Now, it says solution, and we can use our calculator for that. So we're going to go to math, and we need a log base of 3, so we have to go up to A, not down in math, but up. Log base, sorry, I hit the wrong thing. There we go. All right, when I hit enter, notice it's got a little bitty subscripts number for me. So I put in my 3, put my 8 in, hit enter. My answer is about 1.89. This is not super important. I'm just showing you can get a solution in the calculator. Okay? Now, we're going to look at the quotient property, which quotient means division. So here we were. When we were dividing, we subtracted. Notice on this quotient, which is division, we start with subtracting. We start over here, we're going to work backwards to division. Our log bases are both 4, so we're going to write log base 4. Subtraction means division, so we're going to take our first argument divided by our second argument. In order to finish that, we always simplify fractions. We've had to if they're exponents, we have to if we have a fraction, no matter what it looks like. 6 divided by 2 is 3. Okay, so again I can go to my calculator and hit math, up arrow, and you'll see log base. We want the log base of 4, 3, and it is about 0.79. Again, this answer is not super important. I'm just showing you how to get it in the calculator if you're asked. And sometimes you would be. Okay. Now, this is the only one that's not super simple to see. We've got power property, which power means exponent. So we were multiplying when we had 2 exponents involved. Well, this time, we've got the exponent, so we start with the exponent, and we need to work backwards. How do we make it multiplying, right? Well, here's what you do with an exponent. You bring it out front. 2 is the exponent, so it comes out front times the log of 5. Okay, so an exponent comes out front to multiply, right? That's what we're getting at for power exponents. How do I type that in the calculator? This one is different because you have no log base. But over here on the calculator, we have a log button on the far left. That is what we use when there's no base there. That base is understood to be 10. We don't ever write a 10. It is just in log base 10. For a square root right here, we never write 2. It's just a square root. Okay? This is a 10 even though we don't write it. So we do 2 times. We're going to hit log. See how they match? There's no base on either one. 5. So my answer is about 1.3. Oh, that one's going to round up, so it's going to be 1.40. Look ahead. 1.40, okay? So really, really, really important log properties. We've got to know our exponential rules. Okay? So if we know these, we're working backwards. So when we're adding, we're really multiplying. When we're subtracting, we're really dividing. And when we have an exponent, it comes out front to multiply. Now these are some basics of logs that we need to know. And I'm going to put it in the calculator so that you see I'm not making this up. It is actually a true statement. So when we have log base 2 of 2, so my base is 2, my argument is 2. So we go to math and up arrow. Log base 2 of 2. You're going to get 1. This is really important. Anytime your base and your argument match, it's automatically 1. That's a nice, easy rule to remember so that it will help you get rid of logs a lot. Okay? Now, what if you have the log base 5 of 1? So again, we're going to go math, up arrow. I need a base of 5 and an argument of 1. That's 0. So anytime your argument is 1, your answer is going to be 0. And I'll explain why these are in just 1 second. It's really cool. It's from our last lesson. Now we've got log base and argument being exactly the same. Oh, which they were here. So we should still get 1. Sorry, I didn't realize I typed this twice. Interesting. Okay, so let me show you why that is. From our last lesson, we learned to rewrite. Right here, this is saying base stays the base. What was isolated is the exponent. And the argument is your answer. So 2 to the 1 power is 2. So exponentially this is true. That's why it works this way in a log. Over here, my base stays the base. Exponent was isolated. And we learned in our last lesson that in our exponential lesson, anything to the 0 power is 1. I can prove it to you. 5 to the 0, you do get 1. Okay. Same is true here. Base stays the base. That is my exponent that is isolated. 7 to the 1 power is 7. Okay? So these are important log rules. Very important. Now we've got some practice. It's called condensing logs, or we can have to expand logs. We're going to work on condensing, which are these rules right here. So we're going to be using them. So my first problem, I notice that the bases are exactly the same. That's good. Subtraction means division. If you need to write that for yourself, you do that. Subtraction right here means we're really dividing. Quotient is division. Okay? So I'm going to write the log base of 2 only one time. I don't want it twice anymore. That's called condensing. We're bringing it down. 14 divided by 7 is how I read that. 14 divided by 7. Now, again, fractions are always required to be simplified. 14 divided by 7 is 2. Guess what? That's the exact problem I had right here. When the base and the argument match, we're actually equal to. So really I'm going to get an answer of 1 from this problem. Condense, this is the correct condensing. This is the correct final answer because base and argument are the same, so I'm going to get 1. The second one, our bases are now 8. It's still subtraction, so we're going to be dividing. So I'm going to write log base 8 only one time. Condense, make it smaller. Write it once. I've got 18 divided by 2. So my answer is going to be log base 8 of 9. Now, we're told to condense. As far as we're concerned, that is condensed. The reason being, if you do math, up arrow, 8 of 9, oops, nope. You're going to get a decimal, and we're not concerned in the decimal answer. This is perfectly fine as my final answer. Anybody can type that into a calculator to get the answer. So when we say condense, this is what we're looking for. We've condensed it into one log. We don't have 2 logs anymore. And notice here we've got 1, 2, 3 logs. So we're going to condense, and it's going to be into one log, just one. Notice that all of these say log. So that means that I don't have a base there. It's understood. And the first thing I do for myself is I draw the 2 back here. I draw an arrow because that 2 has to become the exponent to that argument. So when I rewrite, this is going to be log of 6, and I'm timesing it by this 2, but that 2 has to become the exponent, so it's 2 squared. Okay? Addition means times, so it's 6 times this 2, but it's got an exponent. Don't forget that. We've got division here, so we're going to divide by 3. So we're going to simplify, so we've got log of 6 times 4, 2 times 2 is 4, divided by 3. I didn't write that well, sorry, 6 times 4. So then we're going to get log of 24, 6 times 4 is 24, divided by 3. And make sure you check in your calculator, 24 divided by 3 simplifies to 8. So when I condense, this is the correct answer at the end. Again, the 2 out front becomes the exponent on that argument. And I square the 2 to get 4. Sorry, you can't see that very well. Let me fix that. So this should be 4. Okay? And 6 times 4 is where we got 24. 3 was division the whole time. Okay? So let's do a second one with 3 of them. Notice that this time I've got log base 4. So I've got log base 4. I'm only writing it one time. Addition means multiply. Subtraction means division. Do I have any exponents? That's what I check for. Yes, this 4 is going to go back onto the x as an exponent. I draw that arrow to help myself remember. So I've got 20 times, it's going to be times x, but it's got a 4th power. X to the 4th, and then I'm dividing by y. The only thing I want to do is write that a little neater, but there's nothing to simplify because that's 20x to the 4th over y, divided by y. Okay, these 2 are just multiplied. I can't do any simplifying because I've got different variables. And so that's it. This is the simplified answer. Okay, and then we're going to do number 5. Notice that I've got log bases are the same, so we're going to go log base 2. Okay, addition means times, subtraction means division. And I look to see, do I have an exponent? No. Exponent? No. Exponent? No. Okay, I've got no exponents. I've got 5 times x, and all that's divided by 10. So we've got to simplify if possible, and 5 and 10 are both divisible by 2. I'm sorry, by 5. That was dumb. By 5. So we're going to get 5 divided by 5 is 1, so we just got 1x. 10 divided by 5 is 2. So that's my final simplified answer. This becomes 1, this becomes 2 when you divide by 5. Okay? So that is condensing logs. Not so bad, you just have to use your rules. Okay? What about expanding them? We're still using the rules, and they've written it simplified for you, and you're going to write it out like this. So on my first one, I have log base 3 of 8. Now they're times. 8 is times. So remember, multiplying means that we were really adding when we're working backwards, so plus. Now we've got x squared. It's got to be log 3 of x, but I don't put the square up here. Remember, it goes in front. If you need to on your problem, you write yourself an arrow so that you know it's moving forward. So again, log 3 of 8, addition because we're multiplying. The exponent comes up front, log base 3 of x. And then I've got y, who is also multiplied, so I'm going to hit plus, or write plus, log base 3 of y. That is expanding. It is the same thing as up here. Up here we took their information and condensed it. Here we're taking it and writing it out. These are the inverses of one another as well. You are expected to be able to do both. It is still using these rules. These logarithm properties, I guess. So, second one. We've got, this one's really important. That 5 belongs to the x and the 9. That is an exponent to both. So we're going to say 5, because it's an exponent, it goes out front, log of x. Okay, that 5 on the x comes out front, log x. Now we've got division, so when we look up here, quotient means subtraction, so we're going to say minus. The 9 also has an exponent of 5, so we're going to say 5 log of 9. That is correctly expanding this one. Number 3, we've got some multiplying up here, which means addition, and we've got exponents, which means they have to come out front. So we're starting with log, except we are working on x squared, so don't forget to bring your squared out front. So log of x squared, I got 2 log x. We're going to multiply, so that means addition. Now we've got y, but it has an exponent of 3. So 3 comes out front, log y. Okay, 3 is the exponent, comes out front, log y. We've got division, that's a subtraction. And then we do have an exponent on the z as well of a 4, so 4 comes out front, log z. Alright, so it is literally using these rules and working them forwards and working them backwards, okay? So that you make sure you understand log properties. We have to know these to be able to solve log functions. So the last one is division, so we're talking subtraction. Exponents on both, so they have to come out front. So we're going 5 out front, log of x. Okay, 5 comes out front, log x, subtract. 2 exponent will come out front, log of y. you're going to be practicing just condensing and expanding in your assignment for this topic.